Hello, this is Xinru. In this video, we are going to take a look at question 671, second minimum node in a binary tree. In this question, we're given a non-empty special binary tree consisting of nodes with the non-negative value, where each node in this tree has exactly 2 or 0 subnodes. If the node has 2 subnodes, then this node's value is the smaller value among its 2 subnodes. So more formally, the property root.value is equals to minimum of the left value and the right value. So we are given such a binary tree and we need to output the second minimum value in the set made of all the nodes value in the whole tree. So basically, we're given a tree, and every current node we visit, its subnode can only equal or bigger than the current node value. So the subnode either non-existing or the subnode, or there are two subnodes. One is equals to the node value, and the second one is bigger than the node value or equal to the node value. So, and our job is to find the second minimum value in this whole tree. So what we need to do, we need to look into the example 1 to find some pattern. So basically, we can get the following patterns. So first pattern is that if we follow the node, because we are given this tree and the root node will always guaranteed to be the smallest value. Therefore, if the node has a value which is same as the smallest value, we say we can say this node is not the node we want, because we want the second minimum value. Therefore, in this case, we can check the node value. We can check the subnode value with the current node value, and if they are the same, then we just visit the subnode of that node, because we know that node is not what we want. And the second rule we can get is that if we constantly go visit the next node when the current node is the same as the previous node, then we will end up to visit the node on the leaf, and therefore we can say the escape condition can be when we visit the node on the leaf, we will say that is not the node we want, therefore we return -1. So basically, if I make it simple, I can modify this tree to add 2 nodes, so that can cover most of the conditions. So if I add 2 nodes as 2 and 3, and in this case, imagine our algorithm goes through from the root node and keeps going to the leaf, because the left node value 2 is the same as the root node value. Therefore, we will go to the next left node and we reach the leaf. And when we reach the leaf, we just return -1, which means this entire path we have just passed, there is not a node that we want. And we need to keep the number 3, because so we need to keep the node 3. So as you can see, node 3 is the right node of the second node. So we can keep the node 3 and allow the node 2 to return this value. Because node 3 is not -1, therefore node 2 can return the value, and then the value can compare with another node, which is node 5. And in this case, we will compare them directly using mass.minimumValue. And after comparing them, we can find out that node 3 is what we want. And in that case, so basically what we will do is there will be a few conditions. So first condition, so there will be two conditions, two possibilities. First possibility is that we only have one option. So it will be the same as if I just clear this and look at the pure example one, we can find out we only have one option if we go through the node when the node is equals to the current node, and we can only find out 5 is the number we want because the left node of the root node 2 won't return anything but -1. Therefore, we can only get 5 from the right node of node 2, and that is one case. And the second case is what we need to compare those nodes. So if I just add 2 and 3 to the left node of the node 2, then we can find out, so the left node will return 3 and the right node will return 5, and then we compare their value. So these are two possibilities. Another possibility, of course, is the same as the first possibility, is that only the right node returns the value, or only the left node returns the value. So they're equivalent. So okay, now let's get into coding. So to solve this question, we need to use recursive function because we have to visit the left node and right node of every current node. Therefore, we need to write some escape conditions. So first escape conditions if the root we are visiting doesn't exist, we just return -1. And if the left node and the right node of our current node doesn't exist, so which means our current node we are visiting is a leaf node, so we just return -1. Why? Because there's only one possibility that the leaf node will be reached, that is only if the current node equals to the previous node and equals to the node before that node, which is equals to the root node. So therefore we just write if root.left and root.right doesn't exist, so both left node and right node of the current node doesn't exist, we return -1. Okay, so after we get those two conditions out of the way, what we need to do is we need to define two variables, which is the left value and the right value, to hold the current left value and the right value. So we just write left value equals to current node we are visiting, left node, this value, and the right value equals to the value of the right node of the current node we are visiting. So after we get the left node, left value and the right value, what we can do is we need to check if the value of the left node and right node is the same as the current node. So what we can do is if left value is equals to the current node, then what we will do is we will update the left value, because we know the current node is not what we want, because the current node will be guaranteed to be the same as the root node. If you follow the chain, you will find out the the current node will always be the root node. Sorry, the current node value will always be the same as the value of the root node. Therefore, when the node value is equals to the root value, we say we will go to the same direction of that value to see if we can reach the next node that has the same value. So what we will do is we will update the left value. It will be the same as, we will call this same recursive function, and we will call it on the left value. And if the right value is equals to root.value, we will do the same with the right value. So we call the same recursive function on the right value. And after we called those recursive functions on both left value and the right value, so what we now need to do is we now need to figure out the three possibility or two possibilities I have mentioned before. So if left value and right value, they are both exist. So if they both exist, which means the left value and the right value, they are not equals to -1. So if left value not equals to -1 and right value not equals to -1, in that case what we will do is just return the minimum of them. So return the minimum of the left value and the right value. And another case is that if the left value and the right value, there's one of those values equals to -1, which means we only return the one value, and another value, the whole path we have visited, are the same as the root value. Therefore, they are not the value we want. So what we can do is return. So I will use a lambda expression. So if left value not equals to -1, what I will do is just return left value. If left value is equals to -1, which means right value must not equals to -1, because in the previous condition, in this condition, I have already ruled out the possibility that both values are -1. Therefore, I can just say if left value is equals to -1, then what we need to return is the right value, and it's guaranteed is not -1. So let's submit my solution. So the most important thing is looking to the creation of this tree and the pattern, and find out the left value and the right value. So we need to create a recursive function and follow the tree, follow the path when the values are the same. So we follow the path, and we rule out the possibility that when the current node value are the same as the root value. So, and in this case we have to use recursive function because if we do we can visit all the node, and we can search all the we can search every level, and we can convert the tree to a node. So we can convert to this tree to an array of node values. Then we find out the second minimum. But that is not what this question is asking. And if we do that, the time complexity will be, I would say the space complexity will be more than this solution, and the time complexity will be probably the same, but the space complexity, and that is not what this question is asking.